Hey guys, I thought we would do an asynchronous lesson today because today is Spearman's coefficient, which is similar to Pearson's correlation coefficient, which is the R value. So we're going to talk about that in a minute. One thing I did want to talk about is the homework from 15B, which I will publish to you guys and make sure you can see it. I really think over Thanksgiving break, this is something you're going to want to spend some time just reviewing. We're going to review. I don't see you guys next week, so that's kind of crazy. I'm thinking about holding a session on Monday, which is kind of the reason I wanted to do an asynchronous day Friday, because I thought I would add a session on Monday during one of the CCE times. I'm thinking 9:30 on Monday, and we could have a little chat to see how everybody's doing now that all three of the hypothesis testing methods are out there. So on your homework, the first one was a t-test with data because you had a list, okay? The second one was a t-test with statistics because you had a mean and a standard deviation. And then number 12 was a set of data. A set of data. So again, you had list 1. And then 13, same thing. You just had, in this one, you had a set of statistics. So it was just the t-test with statistics and plugging that in and getting the values. So this is more about the hypothesis and the null hypothesis, and are you able to write that? So I gave you a warm-up right here over t-tests, and Divya measures masses in a random sample of dogs from 2 different breeds with the following results. Breed A and breed B. Is there evidence at 5% significance level that the 2 breeds have different mean masses? You may assume that both populations are normally distributed and have equal variances. So I would pause this video right now and take a minute and go through this problem and see how you do. All right, so I'm assuming you have paused and you've taken a minute to do this. The null hypothesis is that the breeds have the same mean. The alternative hypothesis is that they do not have the same mean. And this is where is the population mean for breed A, and mu B is the population mean for breed B. Okay, and all you want to do is put this in your calculator and go to stat, test, number 4. All right, this is there are 2 sets of data here. So we want mu not equal mu 1. All right, yes, this is a pooled result. And you're going to end up with a t-value of 0.673 and a p-value of 0.514. All right, so this is a 2-sample t-test, okay? So 0.514 is greater than 0.05. So do not reject H naught. All right, so insufficient evidence that the 2 breeds have different mean masses. And hopefully you're getting better with interpreting what the significance level means and how that works. All right, so previously you know of Pearson's correlation coefficient, which is the R value when determining if there is a linear correlation between 2 variables. So that's the whole linear regression thing on your calculator. You might remember that. All right, and in these diagrams, so diagram 1 is as x increases, so does y. And in diagram 2 is x increases, y decreases. Pearson's correlation coefficient between x and y is 0.843 for diagram 1, meaning we can kind of form a best fit line. We have some outliers, and not so great here, but we can form a negative correlation for diagram 2. However, Spearman's rank correlation, denoted as R sub S, is a measure of nonlinear correlation between two variables. So it measures the extent to which the two variables will increase or decrease together. Okay? And there's only one way to do this, so it's pretty straightforward. To calculate the Spearman's rank correlation coefficient, rank both sets of data in order of magnitude, calculate the Pearson's correlation coefficient between the ranks. Okay? And then you'll see this is going to give us the Pearson's correlation between the ranks gives us the Spearman's correlation. All right? Sounds a little confusing, but we're going to show you what that means. In the two examples on the previous page, replacing actual data values by their ranks turns the graphs into straight lines, which is pretty cool. All right, so this is what the Spearman's rank would look like. All right, so Pearson's correlation coefficient only detects a linear relationship between variables. Spearman's can also detect a nonlinear relationship. Pearson uses the actual data values. Spearman uses rank only. And Pearson's is more affected by outliers, like I showed you up here. If you have a couple outliers, it's really going to mess up your line of best fit, so to speak. All right, so here we have an example. I forgot to type part of it, but here you go. 8 students took a chemistry test and a history test. Their marks are given in the following table. I want you to A, calculate the Spearman's rank correlation, and B, find the critical, given the critical value of correlation coefficient for 5% significant level is 0.643, state the null hypothesis, the alternate hypothesis, and is there significant evidence. So we're doing the same thing that we did before. We are just now using rank. All right, so you are going to remake a chart right here with student, chem, and history. And our student, we have student 1, student 2, 3, 4, 5, 6, 7, 8. And you are literally going to go through here and in this chemistry mark, what is the smallest number that we have? 34 is the smallest number that we have, so this person is ranked 1. The next smallest number is 41, so this person is ranked 2. The next smallest number is 42, so person 5 is ranked 3. Then we've got 48 and 50. And so this will be the 6th ranking, the 7th ranking, and the 8th ranking. All right, so you're just putting them in order from smallest to biggest. In the history marks, our smallest history mark is 66. This is what your rank should look like. 5, 3, 6, 2, 1, 7, 4, 8. Just ranking the scores from greatest to least. Then what you're going to do with that information is what we normally do. Stat, edit, and put the ranks in list 1 and list 2. All right? Then you're going to go to stat, test, and I think it's letter F, which is the linear regression t-test. And it should be, L1, L2 is what you want to put in. All right, so R is the rank correlation coefficient in our calculator. That's what it spits it out as in this test. And you should get 0.690. Now, somewhere we needed to state our hypothesis. Our null hypothesis is that there is no correlation between chem and history. And our alternate hypothesis is there is a positive correlation between chem and history. All right, so we had this information at a 5% significance level. Will this test work or not? 0.690 is greater than 0.643. So there is sufficient evidence to reject the null hypothesis. All right, so 0.690 is greater than 0.643, so there's significant evidence to reject the null hypothesis. So there is sufficient evidence at the 5% significance level that there is positive correlation between chemistry and history marks. Okay, so that's what we got for that example. Okay, now we have another example. Miriam works at a coffee shop. She wants to find out whether there is any correlation between the sugar content of a drink and the number of people who buy it. She records this information for a sample of 10 drinks over a period of time. All right, so calculate the Spearman's rank correlation coefficient for this data and test using a 10% significance level whether there is any correlation between the sugar content and the sales of a drink. So you should try and pause for a minute and see if you can kind of figure this one out on your own. And the first thing you want to do is start by making a table of your ranks. Okay, now something here that we need to talk about. If we look at our sugar content, so we're looking at this very first line, we have 12, which is definitely our lowest, but then we have 15 and 15. So this would normally be ranked 2 and 3, but since they're equal, you average 2 and 3, and this will be ranked 2.5, and this will be ranked 2.5. Okay, so we've used up 2 and 3, so then this will be 4, 5, 6, 7, 8, 9, 10. Those are all in order, which is nice. These in our next grouping down here are not all in order. So we kind of have to look at this and find out, all right, where's my smallest? Looks like 12, which would be here. All right, so again, go through this. So 12 is the smallest, 23 is our next smallest, and then we've got 25, 25, and 25. All right, so that would represent 3, 4, and 5. If you average 3, 4, and 5, they are all just 4s. Okay? And then you take off where you would be next. So we've used 3, 4, and 5, and so now we need 6, which goes here, 7, and then this is actually 9, 8. Where did I mess up? Somewhere. I should have 4, 6, 7, 4, 9. I've got my numbers in the wrong spot, don't I? That makes it challenging. What have I done? Oh, I've got them all shifted, you guys. Why does nobody tell me these things? See what happens? I had them in the right spot. I just have them all shifted. Okay, so based on the logic of what I was just saying, this should be 4, 6, 7, 4, 9, 8, 1, 10, 4, 2. So hopefully, while you were paused, you did this correctly and your rank table looks like my rank table. Just make sure when you have things that are the same, you would rank them as what would their numbers be and then take the average of them. Okay? So part B says test using the 10% significant level whether there is any correlation between the two. Okay, so again, you put this in your calculator. You should end up with an R value of negative 0.172, all right? And our null hypothesis is there is no correlation between sugar content and sales. And our alternate hypothesis is there is a correlation between sugar content and sales. And so this said at the 10% significance level, the critical value is 0.564. So we are going to look at the absolute value of R sub S because we're looking at the correlation of it, not whether it's negative or positive. So we would have 0.172, which is less than 0.564. So there is insufficient evidence to reject H sub naught, which means there is sufficient evidence at 10% significance level of a correlation. So insufficient evidence at the 10% significance level of a correlation between sugar and sales. All right, so now we're looking at specific R values in terms of the critical value for a test. So that's how we're determining whether there is significant or insignificant evidence to reject or not, okay? This next example, match each graph with the corresponding values of the Spearman's rank and Pearson's correlation coefficient. All right, so looking at this guy, this is a very straight line. So we know in our old school Pearson correlation coefficient, let's just write this down. All right, so we have A, B, C. So we know that big graph B is going to go with A. This is going to go with this information because if we have a straight line, then both of our Spearman and Pearson's correlation coefficients will be 1. All right. Our little information B has a relatively straight line. So now again, we're looking here, has a RS of 1, but an R of 0.7. So this is saying that our Pearson correlation, there is some correlation. So that has to be which one? So little point B, and then this guy over here, little c, is saying that we have a little bit of a Pearson regression, so a little bit of a correlation and almost a better fit line. So little b goes with big graph C and little c goes with big graph A. Because if you look up here, this part of the data has a pretty good fit. So that part of the data with these outliers shows that we have a pretty good fit. This has much less of a positive fit, even though we could put a line through here. And so that is going to go with this. Okay, so I kind of wrote all over those, but let me undo those for you, and you can kind of look back at those and see how those line up. So little information A goes with big graph B, and little information B goes with big graph C, and little information C goes with big graph A. All right. Here is our last example. For the data in this table, calculate the Pearson's product moment correlation coefficient. Okay, so this is our regular linear regression, like stat, calc, lin reg. So this is going to go in list one, this is going to go in list two. Okay, if you're doing the Spearman's, you have to rank these first. Rank first. So for part one, if you put those in part AI, if you put those in L1, L2, and then do stat, calc, lin reg, you should get an R value of 0.879. And then this is part two. You need to rank all those things. All right. So we've got 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. All right. So you're going smallest to biggest. This looks like the smallest. 1.6 looks like the next one. 2.1, 2.8, 3.2. So we've got this is the rank for this. And then in the bottom, 11 is the smallest, 13, so I've used 11, I've used 13, I'm going to use 18, and then 25, and then 37, and then 38. I didn't have any equal numbers, so I didn't need to do any averaging. So then put this in L1 and put this in L2, and I don't know why I keep making that an I, but then you're going to go back to your stat, test, lin reg t-test. All right, and put in L1, L2, and you should get an R value, or an R sub S as we will call it, but 0.886. So this is asking, notice this is very close to this. So overall, the correlation, which is asking for between the two sets, is a strong positive correlation. Because the closer you are to one, the more strong and positive it is. All right, so hopefully that made some sense. Like I said on Monday during CCE at 9:30, I would like to have a mini class to go over all of this and just make sure, kind of make a little summary of 15A, B, and C, and kind of set everything straight and put it all together. So please make sure you attend this, because that will be the only time I see you next week, and I really wanted to see you one time before an entire week goes by. So put a note, make that happen, and I will see you on Monday at 9:30. There are I think 3 or 4 homework problems of just interpreting this, and it's basically all about how do you put it in your calculator and make sure you're ranking it. So I hope you guys have a great